Imagine a world where the laws of physics are incomplete. Where the deep connection between symmetry and conservation laws remains undiscovered. This was the world before Emmy Noether. A brilliant mathematician who revolutionized physics, yet was nearly forgotten by history. This is the story of the woman who changed everything. Born in 1882 in Germany, Emmy Noether was destined for mathematics. Her father was a professor, and numbers fascinated her from a young age. But there was a problem: universities did not accept women as full students. Determined to learn, she attended lectures unofficially, listening from the sidelines. Finally, in 1904, she was allowed to formally enroll, and she quickly proved herself to be one of the brightest minds in mathematics. In 1907, Emmy Noether earned her PhD in mathematics, one of the first women in Germany to do so. But even with her doctorate, she was not allowed to hold a paid teaching position. For years, she taught at the University of Göttingen, without pay, without an official title, because women were not considered qualified to be professors. And yet, she kept going. Then came the moment that changed everything. In 1915, Albert Einstein had just developed his general theory of relativity, but there was a problem. Scientists struggled to explain why certain energy conservation laws didn't seem to apply to curved spacetime. Emmy Noether tackled the problem in a way no one else had. She discovered a deep and fundamental truth, that every symmetry in nature corresponds to a conserved quantity. This became known as Noether's theorem, one of the most important discoveries in modern physics. Her theorem proved why energy is conserved, why momentum remains constant, and why the laws of physics don't change over time. It became the foundation for quantum mechanics, particle physics, and nearly every modern physical theory. Despite her monumental contributions, recognition came slowly. In 1919, after years of fighting for her place, she was finally given the title of professor at Göttingen, though still underpaid and undervalued compared to her male colleagues. When critics objected to a woman being a professor, mathematician David Hilbert famously replied, "This is a university, not a bathhouse. Why can't a woman be a professor?" But just as she was gaining the recognition she deserved, history took a dark turn. In 1933, the Nazi regime expelled all Jewish academics from universities. Emmy Noether lost everything. She fled to the United States, where she was given a position at Bryn Mawr College. Despite the hardships, she continued teaching, inspiring a new generation of mathematicians. Even in exile, even after losing her homeland, she remained dedicated to knowledge and to her students. In 1935, the world lost one of its greatest minds far too soon. But her work did not die with her. Noether's theorem became the foundation for modern theoretical physics. Today, it guides research in particle physics, cosmology, and quantum mechanics. Her influence stretches across the cosmos, woven into the very fabric of physics itself. Today, Emmy Noether is remembered as more than a mathematician. She was a revolutionary. A woman who saw the universe in symmetries, who fought against prejudice, and whose ideas reshaped science forever.